And we're live. Okay. Hello everyone. This is day 46 of studying compilers every day until I land a compiler role. The list of to-do things this time looks really long, but I promise this is not intended to be what I get done today. Realistically, I think I'm only gonna get this done. The rest of this is kind of a bit of a roadmap for myself, just to figure out like the remaining stuff I want to do before I get this branch merged and I guess just all merged into main. Last time we finished implementing mem to reg for real, for like the third actual real time. So we need to get tests written for that, but I'm thinking tomorrow is going to be a little bit of a shorter stream, so I'm going to save it for that. In the meantime, the code quality of the code we generate, it's passable. There's a couple of control flow things that I think we can clean up a little bit. So my intent is to get that done today with a simplified control flow graph pass. And I'll refer to like LLVM's sort of their docs on how they do that at least. But for now, we should first do the leetcode daily. Because always that comes first. Okay, is it just triangle week? Is that what's happening here? Like, yeah, we got triangle, now we got valid triangle number. Okay. Turn the number of triplets chosen from the array that can make triangles if we take them as side lengths. Okay, this feels a little bit like threesome, if I'm thinking of this correctly. Yeah, so a valid triangle is if the shorter two sides add up to be greater than the third side. So we can kind of iterate through this in a similar way. Yeah, is num sorted? It doesn't look like it's sorted. Okay. Binary search, yeah, okay. So let's sort this. Or we want, that's not how we do it. Okay, this should sort that. So we can sort, we can keep count here. And then what do we want to do? I guess we can iterate through. We can iterate top down, I think. Because once we hit a certain point with the short side, actually, let me think about this. Yeah, we can iterate top down actually. We can like sliding window, I think, almost. This is like such a funky problem, but okay, let's give this a shot. Okay. So we want A, we want, oh boy, I can't type today. That's what the discussion is saying. Yay, okay. Alright, I guess, would it be easier to, or I guess we kind of have to start with two sides, and then we can make the third from there. Or we can start with a third side and then pick all of the 2 sides that are valid. Yeah, actually, that could work. Let's give that a try. So A will be the short side, I guess. And then so then B to be A plus 1, and then C to, oh, this should also size minus 2 actually, because we can't have overlap. So C will be num size minus 1 actually. So then A plus B must be greater than C. So then, so we want B to be less than C. Those are the cases we check. So we want B equal, I guess like, so we want to increment B while it's less than C, I think. Right? Yeah, and then we can, yeah, this should make sense, I think. So we want int AB, so we want A plus B, and then if AB is greater than C, and res is plus, and then we can do it like this. We can increment, and then what else do we want to do to it? I guess we could increment as we decrement C. I think that's what we want, right? We could just increment B, I think. Hey Janine, how's it going? If it doesn't fit, then we want C minus minus, I think. Does this work? This feels slow as well. Okay, this is not the answer we were looking for. Okay, so all the possible A's are 2 here. So B and C start at 2 and 4. This isn't valid, so I guess we should B++ here. Why is this borked? Oh, I see. Nums at. Yeah, nums. Also, apologies to y'all for the really late stream today. It's a little bit tired, but that's how it is sometimes. Oh, wait a second. How is this getting 2 now? Oh, wait a second. Wait, we can do some things here, I think. Okay, we should swap these back, and then Let's go to add. Actually, we can do a different way, I think. Right? Yeah, we can do this differently. Maybe I'll do an inner while loop here. I'm getting lost in this logic here. So we start at 224, and that's invalid. So we want to increment b, and that's valid. So we add num size minus c actually. So let's. This was fine, and then. Alright. Or we could even... how do we iterate through this properly then? We can do it like that. And we also want a quick while loop here. Guess we want to keep incrementing b there. And then we need to like decrement c, I think, right? I feel like I've lost the plot a little bit here. Is this the intended? I think this looks. Oh, this is very much not right. Low-key, I'm low-key too tired for this. I'm just gonna look at the editorial here. Binary search, linear sum, n squared log. Oh wait, I could have binary searched this? Wait. You know, check all three inequalities. Yeah, so this is what we figured out. Oh, I see. We binary search at each A. We binary search for the range for BC, I think. This makes sense. Okay. So what's the linear scan way then? Let's go, Daddy. What is this linear scan? Okay, so does this need to be sorted? Oh, n log n, or the n squared dominates, so the log from sorting doesn't matter. Okay. Okay. Oh, wait, okay, yeah. This makes sense now. So it's just a sliding window, okay. I low-key lost the plot a little bit here. Yeah, let's change this up a little bit. Yeah, we can sliding window inside. That's the part that I didn't realize what we could do. Should iterate across B, I think. Right? Is that what's suggested here? Oh, C is the, oh, I see. Okay, I see why this is not cubic time. Okay, so we make C here. So we want A plus 2. This is A plus 1. I want to do this. So now we iterate across the inner one as well. So on int AB, nums at A plus nums at B. And then, so while AB plus, or AB is less than equal to nums at C, we want to just keep incrementing C, I think. Alright. Alright, wait. No, while it's greater than. Yeah, we want to do that. Increment C. And then we want to add C minus AB? Or it's like, or B. C minus B gives us the range of C's here. And we also want a -1 from that as well. Okay. I think that's all we need, right? What the fuck? C is less than num size. Yeah. Okay, there we go. That problem makes sense to me now. I haven't thought about, oh fuck. Are you serious? Okay. Size T. Size T. Size T. The rest of these are fine. Okay. What? Oh. So if the size is less than 3, we want to turn 0. The rest we can handle. Should be fine. How the fuck did we get -1? Okay. we can just skip like that, I guess. Are you serious? Okay, what is the difference? Oh, wait. No, this is, wait, what? C is less than that, and the fuck? Oh, why is it Java? What the fuck? What are we doing in this editorial? What the fuck is leetcode doing? Yo, who wrote this shit? Like, actually, who thought this was a well-written editorial? Oh, wait. Wait, what? Oh, right. Okay, we need to skip the 0 for that. Right, and then yeah, this should be fine, right? Yeah, because 0 is always going to be the smallest value if it exists. Yeah, okay, that makes sense why we're checking there. Yeah, okay, cool. Faster than this big spike, by the way. Oh, someone else did try to do the right-left shit. Okay. Yeah. Okay. Anyways, I don't particularly care about the leetcode today. I'm quite tired. It's like 10:20, and this is definitely my fault for streaming late, but so it goes. Anyway, the thing I want to implement today is a simplify control flow graph pass. And just as like a reference, I believe LLVM has a simplify control flow graph pass that lists sort of what I want to do here. So we want to get rid of fees for blocks with a single predecessor. We want to remove blocks without predecessors, or I guess yeah, because they're inaccessible. And then I guess if there's a straight line connection, or like straight line connection and the block that's connecting to only has one predecessor, we can merge the two. And then a block that is just a unconditional branch we can collapse, I guess. So yeah, let's give this a shot here. And the reason I'm doing this is because the code that we're generating is kind of a mess. If you look here, there are certain labels that was it this one? There's at least one example where where am I? I see. Yeah, there are some tests at least where the code generated was a little bit ugly and there was like a little bit of random orphan blocks just sort of sitting around. So I'd like to get rid of that if at all possible. Let's do, I think the, just if small is a, or no, if small is fine. Maybe fee insert. Oh, that's the one we're doing. dt.c perhaps. Yeah, like what is this duplicate fee actually? Why is there a second fee here? Oh, right, for return value reason. I see. Yeah, that's a little bit messy, but it makes sense why that exists, I guess, to some degree. We can clean that up later, at least. Okay. I think there are some blocks that just never get used somewhere. That one gets used, this one gets used. I think, is this one, for instance? No, this exists. I'm trying to find a good example, sorry about this. I definitely had one somewhere. It might be in the if test, actually. Yeah, a good example here is blocks 4 and 5, because we literally never get to them in here. Entry goes to 0 and 1, 0 goes to 6, 1 goes to 2 and 3, and 2 and 3 both go to 6. So 4 and 5 are just completely dead, and we literally don't pull a value from 5. So it's like 4 and 5 are like fully inaccessible. So we can hopefully get rid of them in some fashion. And we can also probably collapse these blocks down in some way. So yeah, let's go here. Yeah, let's make like simplifycfg, and then a C++ file. I can probably steal all of this mem2reg stuff at least. I don't think this requires any analyses at least, so that reduces the work we need to do a little bit. We can get rid of that. This is simplifycfg. Yeah, we don't need to register any analyses there. We don't need any of that. We don't need the replace use visitor thing, I think. Yeah, this should be pretty straightforward at least. Yeah, so we want to include, oh wow, I can't type. This, and then let's just paste that in, I guess. We don't need the override here. Okay. So we can get functions, and then each basic block in the function. We can nuke that actually. So for each basic block, we want to check. The only basic block without predecessors that we want to keep is the entry block. So, yeah. So if it has no predecessors, we can just delete. We also want this to be like a fixed point algorithm, I think, because something that has a predecessor which has no predecessors itself will then become a dead block. So we want to continue running it as such. So we want bool changed equals true, and then or false, I guess. So while not changed, actually no, while changed, yeah. So we want to set change to false. Okay, that cleans that up a little bit. Okay. Remove if no predecessors. That's one instance. We want merge if straight line connection. You want use for blocks with single successor, and then we want to squash blocks with, I guess if it only has an unconditional branch, that would get squashed? Oh wait, no. There are some instances where it wouldn't get squashed. So like, let's open up paint.net. No, I don't want to update. Let's say we have these two blocks. Something enters them. These two, like, set x to something, and then y to something. And then at this merge, this just does nothing. And then this branches off to somewhere, which also joins from somewhere else. So we want to just directly replace this block. We don't want to replace this block and the incoming edges with just edges to this, I guess. If there's a fee, then like we can't do this. But if it's like literally empty, then I guess hopefully we're able to do this. Okay, cool. Alright, let's give this a shot. So if it has no predecessors, we can just remove the block and go on with our days, go on with our life. So if this is empty and it's not the same as the entry block, then we can, I guess we want to mark for delete. Yeah, this is awful. Yeah. So we want a vector of size t to erase. What's wrong here? Split vector. So if this, then we want to, oh wait, we still need the braces. We want to continue. So we want to erase. Want to add. Okay, we want. How did I iterate across these in mem2reg again? It's under here. What's good, Aiden? I'm implementing a simplify control flow graph because when I generate code now, it makes a little bit of a mess. So like for instance, this is like a control flow graph. Each of these blocks, we start at entry. At the last instruction always determines like which block we go to next. So here we go to either 0 or 1, like 0 or 1. These are all pretty trivial blocks because they're quite empty. So hopefully we're able to clean this up a little bit. Also, we just physically can't get to blocks 4 or 5. So the idea is to get these deleted and then maybe replace some of these branches with just skipping the intermediate block in some way. So yeah, hopefully this is not terrible. Yeah, okay. What does the fee represent? So in this intermediate representation, we don't have variable overwrites. So anytime we overwrite a variable, we have to pretty much create a new variable and then write the value to that. But then the problem is like, if you have a variable being overwritten in 2 different branches, you don't know which value to use when they join. So the fee is just like, I think it stands for like phony, which is really funny. But it basically says if control flow comes from this block, use this value, for instance. So yeah, it's not like a real instruction. It's kind of just like, I guess, a data flow abstraction to make static single assignment work. Okay, it looks like I'm just gonna make a blocks thing here, I fear. So we want get blocks. We want to iterate by index because erasing things is annoying. So let's want size t. We got end, and then you can iterate like this. What's wrong here? Yeah, it's, I guess, not necessarily every value, but just like where we would get the value from. So like if it lives in a variable somewhere else, we would just stick that variable there. Oh, right, because BB doesn't exist here. This is blocks at end. Oh, right. This is... Okay, so we want to erase this block, so we want to push back end, and then continue. Trying to do OS this weekend? Yeah. Low-key, I'm like out during the day Saturday, so it might end up being a Sunday deal, but I'll probably have time like Saturday night, hopefully. Okay, we can start with this for now, I think. This should at least clean things up a little bit. Sunday better? Yeah, fair. Okay, yeah. I have like solar in the afternoon, so fuck. Yeah. That sucks. Okay. We'll figure it out. If you want to changed to true, by the way. Yeah. we'll definitely figure something out at least. It's a fucking project. It needs to get done. All right. Yep. Take care, man. Take it easy. Okay, so in theory, we've iterated over all the blocks here. So now we want to deal with all of the removals. So when's the project due? I'm not sure. I think we have 2 weeks for it, but starting early is always good. Yeah, okay. Last time I was trying to reason about the best way to, I guess, modify, like, make all changes at once to a base, like, the body of a program unit, I guess, whether it's like a basic block or like a function. What we ended up deciding was we iterate across the vector and we just make all the changes at once. And then we just like make a new vector and then we just swap at the end. So yeah, so we want to iterate a class. All right, we want this size t thing again. So we want The other thing I'm wondering is if we need to worry about like uses either. We'd also have to get rid of the block from like the previous one's predecessors list as well, I think. Or like all of its successors predecessor lists. But yeah, this should be fine. We can figure this out. So we want to erase. We also want to erase end, which is really funny. So I'm gonna do this. So if this is the thing, then we want to erase end plus plus and then continue. Otherwise, oh wait, we need to block clean up. We'll figure that out once we get there. Otherwise, oh, we also want new body. I don't think we're gonna be inserting blocks at least, so I think this cleans it up a little bit. I think unique footers, right? So we want basic block. New BBs. We want blocks size. Yeah, we can do it like this. So we want erase, make changes. Okay. Maybe a hash map's faster, but or this is ugly, but this is fine. So we can do this, and then we want new BBs, push back. Stood, move, and then blocks. Let's call it BBs actually. Okay, so that does that, and then we want to swap. So we want f get basic blocks swap. And we want to swap with new BBs. Okay. We can call this like commit changes even. Okay. So, okay. We need to do a cleanup now. So, what do we need to clean up here? We want to, let's look at what a block contains at least. That might be a good start. Okay. So as the body, that automatically gets cleaned up. It has literals, that gets cleaned up. Then terminator gets cleaned up. So we need to just clean up the so yeah, we need to clean up the predecessors and the successors, I think. So auto pred in. So we want what's on the menu? I'm implementing simplifycfg. So just cleaning up the control flow graph, getting rid of ugly, getting rid of like blocks that only contain like an unconditional branch, getting rid of fees in blocks that only have, I guess, one predecessor, getting rid of blocks that have no predecessors, just like that sort of normal stuff. Also merging strict straight line connections is what I'm coining it. So we want BBs at end. So get predecessors, and then oh, that's a vector. Yeah, so we might just have to do like a little bit of linear search, but that's fine. So pred get successors. I'm gonna erase so we want pred get successors, then we want to find there should be a way to find first stuff. I forgot what it was. Did find exists, I think, right? Is there like a... It's like find first of, right? Oh, this is a string, right? Wait. Sorry, I'm just looking at docs on the side here. Oh, okay. Yeah, we can just use find first of and call it a day. So let's include yes, I know this is a linear search, but honestly, I don't think this is that much of a cost to pay. Yeah. Real quick. Pointer to deleted. Yeah, we need to get rid of this one even. How can you stay consistent? I have the whole internet judge me. Yeah, that'll... Yeah. Oh, it doesn't become... Okay, so we should just linearly search and delete it. Yeah, so let's want stood find. Yeah, so we can just use find. So we want successors begin, successors end, and then we want v.get. Okay. Yeah, so we should do that, and then we can kind of do the same thing in the opposite direction. Actually, we can change some names to be shorter. I also just think it looks funny. Yeah, okay. Yeah, so this cleans up predecessors and successors, and then, yeah, and then we kind of just drop the basic, or we drop the basic block pretty much, as in we just don't add it to, we don't add it to the next pile. And then uses doesn't really matter anymore because we don't, oh wait, yeah, we shouldn't, I don't think we need to worry about uses here. So if it gets to a point where we need to, then we can figure that out once we get there. But until then, I think it's fine. Yeah, okay. So we can do that. Let's add this to our passes list real quick. This goes in here. And then we want, let's steal that. This should be, so this should be simplifycfg. Do that. What? Oh, I need to import it. Okay. So that adds that, and then I'm gonna move that. Okay, make. This should at least get rid of blocks 4 and 5 here. That should be a minimum. Okay, so it doesn't do anything. That's less ideal. Why doesn't this do anything? wait a second. This is the wrong pass. All changed. Oh, this should be true by default. Okay, that's not what's supposed to happen. The fuck? Let's do that. That's a lot of memory. P thread kill input what? Sigabort. It's in here. Bracket operator. That one should be fine. This one should be fine. This should be fine. Alright, we should even just like put this here. So we want BB. This is the only other one. Why is this working? N is, what is N? Okay, do I have make debug here? That. Do that. Do that. Yeah, this looks about right. Oh yeah, we need to rebuild with debug symbols. Alright. I just want to see where this is breaking, so. Yeah, this might take a second. We want LTB. So we want run. run, and then we want okay. This does not help me. This does not help me one bit, actually. How could this also help me so little? Bro, do you also forget syntax and feel weird? Yeah, it happens very frequently. If you just like stick around on stream, you'll definitely be able to count the number of times that happens. What language are you using? I'm using C++. Let's just run Valgrind on this. Oh, wait. This gives me a line number. 37. Oh, wait. What? Do you use any book or website to learn it? I mean, I guess I'm just like learning through osmosis, just like using the C++ docs at least. Just like C++ reference. I'm not going through anything like formally though. I don't really see a need for me to, at least. Why is this not working? I'm gonna push back index here. Why is this comparison broken? Oh, wait a second. I think I know why. Because the size changes. How do I deal with it here? Wait, what? The fuck? Why is this? This doesn't make sense to me. We have BB's size. It should be fine. I want to throw this into ChatGPT. I feel like I had it at least. Oh, I need to yank to clipboard. It's going to tell me, I see where the problem is. Wait, what? Oh, if 2 erase is empty. Oh, I did not think about that, actually. This is in a loop, so we can just this, and we can continue the loop. What? This is sorted. I'll just rename these to be a little bit more clear for myself. Let's rebuild debug. What else did it say was wrong? Oh, wait, what? Oh, wait, I see. I see what's happening. Did I also run into something similar here? Oh, I should probably do that anyway. We want to erase size. Okay, this should solve the problem. I forgot there are cases where it does not in fact, or the last one erased is not in fact the back. Okay, yeah. It looks like this does do the simplification. At least to some degree, 4 still exists, which is strange. 4 should not exist. Why does 4 still exist? Yeah, that shouldn't exist. Yeah, we'd have to do it this way. I think. Yeah, okay. Actually, no, we wouldn't. We should probably put this slash in here at least. So we want to insert that. Do that. Why is this? Why does this pesky for block? Why does it still exist? It shouldn't have a predecessor anymore. Let's include stood IO, or was it IO stream? That's what it's called. Yeah, there's an example. There's an example of me forgetting syntax, or forgetting what a library is called. This should run 3 times, I believe. At least 3 times. Okay, so it runs way more than 3 times. Something seems wrong. This is per function. Yeah, okay. So, okay, that should be fine. Let's just steal this one. Dude, there's so many different print libraries off the top of my head. IOStream is like the least intuitive name, at least to me. Yeah, it's quite a travesty. So we want cur.c. Okay, so it runs twice, which is bad. It's bad because we want to run a 3rd time. Because that means it found block 4 this time and was like, yeah, that's fine. Stood print, it exists, but also like, why? Like, I understand why it exists. Initially I liked it. The more I think about it, the less I like it though. Like, it's just like, truly, just why? Like, why would I use that when I could literally just use IOStream or like an fprint? Okay. Oh, wait. This should go here. Yeah, okay, so it runs this once. Yeah, I guess the double arrow operator does look a little bit funny, but I don't know, it kind of makes sense to me at least. Let's give this a ChatGPT real quick. Oh wait, I need to give it the whole thing actually, I think. Is the yellow block? Yeah, okay. Why doesn't this enter basic blocks that have already been deleted? Or with one predecessor which had been deleted. Oh my god, wait, I might be tripping, yeah. Wait a second. Right? Yeah, this should be good eye from ChatGPT. Saving me like 20 minutes of staring at my code, I guess. Okay. This still doesn't do what I want it to. Oh, wait. Wait a second, wait. This is also not a reference, I think, right? Yeah, this needs to be a reference. There we go, okay. That works now. So that little bit works. Let's actually just get rid of debug here. I'll add that properly at some later point in time. Okay, that does what we want it to. This is fine. We don't need IO stream anymore. Let's try one more time. And huzzah, it works. Okay. Let's just add this real quick. simplifycfg build out. Okay, so that's the first little one. If we go back to the docs, so we've done remove basic block into predecessors. Next, we want to merge a basic block into predecessor if there's only one and the predecessor has only one successor. Yeah, so this shouldn't be that difficult in theory. It's a little bit more of the same. Yeah, so this just smushes together straight line connections. Yeah, so we can do that right here. So we want to get predecessors. So this we want to be 1 and predecessors. Oh wait, we should probably just like straight up like oh wait, we should probably just straight up get predecessors here real quick. We can save a couple calls. Yeah, so we want, this will, I think this should overwrite at least, or it should shadow in the local scope. So we want preds empty. Yeah, we can clean that up. Actually, wait. Big T? No. Okay. Well, I don't know my Vim bindings as well as I thought I did. So successors here. C++ erase if found in vector. Is there like a straight up... Oh, erase if. Oh. Wait, what? Wait, we can just... Wait, I can just do that? wait, this is... No way. So an erase... What is std remove? Erase if, okay. Oh wait, we could do what? Okay. Okay, so we can... Where does this come from? Let's try this at least. So we want head get successors and then bb get. Yeah, okay. Well, that makes it way quicker. Or way cleaner, actually. So here, let's just comment this line out real quick. Just so this cleans up. Okay. We should also just get like the basic luck putter real quick. We can do like this even. Okay, well that makes things a lot less messy. Yeah, okay. Is there an instance here where we want, or like, I arrow? What happens with I up here actually, for each instruction? Okay, well, let me clean this up as well while I'm at it. Do that. Yeah, and that even like flattens it out a little bit. We don't use IOStream anymore? Oh no, anyway. Okay. Okay, we can get rid of that now. Let's get rid of this line real quick. cleanup, to reg and simplify. Okay. Okay, now we can do something with this goddamn if statement. So we have a straight line connection if pred size is 0 or is 1 and preds at 0 dot get successors size is also 1. That means we have a straight line connection. So then how do we want to merge this up? Okay, so we can merge these, I think, right? Right? Is that... There's only one, and it only has one successor. Okay, so then yeah, this is the only instance here. So then, the fuck do we do here? Yeah, so we can just get all of its instructions, I guess, and we can stick it into the predecessor. This shouldn't have any fees in it, at least. If it only has one successor, or one predecessor rather. So we want basic block, instructions. We want so we want PP, we want preds at 0. We want pred. So we want pred, we want push back, and then I'm just gonna throw in an assert here because I'm actually not sure. Let's just try. So we want we want to make sure it's not a instruction fee putter. I get and push back I or move I. We don't need that either, I think. Okay. Okay. So this pushes back all the instructions, and then we need to do this the whole mess again. But it's a little bit less awful. So then I think we can just like we can swap the We can, so the pred will be fine. So we want pred dot pred get right now. So this, and then we want pred. Okay, we can do that, and then we want pred successors to just equal, or we could even just like swap here, right? Yeah, we can do that. We can swap with successors. We need to clean this up though. So you need to erase that, and then, or we could even just do a quick replace, right? Stood replace? Oh, we're so up. So we want to so we have stood erase. So is there a replace equivalent here? Nope. Okay, unlucky. Worth a shot. Okay. So here we want replace. This one I'm a little bit more willing to clean up a little bit. So we want preds, sock preds, predecessors, breads. Wow, I can't type. We want begin, and we want to replace first with second. So we want to replace all occurrences of the basic block with pred. Yeah. Okay. This should be functional now. Oh yeah, and then we need to add to erase, I guess. We want to get rid of the current block, so we do that. I really hope this runs properly. Okay, well that was a bad example, to be honest. What other tests can we do? Are you using LazyVim? No, I'm using the NeoVim config that I wrote from scratch. It's in my dot files, which are in my GitHub, which is in the description. Let's just test with if. I guess. Oh, fuck. This always happens. happening? Let's paste into cur, I guess. Wait. Just comment that. Okay, well, it's already failing. That's not ideal. Why would this be breaking? Let's try that again. Okay, so this does exist. Why could this possibly be borking? Just do that real quick. Let's give this a test. Okay, so the other pass just does nothing. Yeah, this shouldn't run on this, but it also just shouldn't crash. Why do we do the crash? Maybe I just make this break even, to be honest. Just one change at a time. That feels like the only safe way to do this, but this also feels just like so slow. Oh, wait, I see. This should be trying to merge 2 and 4, I think is what's happening here. Right? Is that what it's trying to do? I think that's what it's trying to do. Yeah, it looks like that is what it's trying to do. So then why do we do the break though? Oh wait, it needs to swap terminators as well, I think, right? That might be why it's breaking. Yeah, that makes sense actually. Yeah, okay, yeah. Let's do that real quick. This is fine, and then to erase we push back. We want pred, get terminator, swap with we get terminator. There we go. Okay. Okay, Okay, so let's go back to cur.c. Let's uncomment that. Okay, it all builds. That's pretty neat. It's pretty neat if I say so myself. Yeah, this code quality is a little bit less miserable now, which is very ideal. And I think that's already cleaned up most of it for what it's worth. Yeah, like, I think most of the uses are also still fine. Yeah, like this folds the return block in, which is really, really helpful. We can get rid of this little stuff though. I guess not really though, huh? This is a very interesting case. Yeah, that's a little bit interesting. I don't really like that control flow graph, but I think that it kind of breaks the fee if we don't do that. So, yeah. But also, like, what is this shit? Okay, I'm gonna see if ChatGPT has ideas on how to simplify this, because nothing is coming to mind for me at least. Let's make a new chat. Wow, it's really struggling. Alright, we're really plugging in all the assumptions. Select? The fuck, that's a thing? That's interesting. That's interesting. That's interesting. Oh, wait, that's useful. Oh. Okay, well, I've decided there's nothing I can do about that right now, at least. The issue I'm running into here is for this program here. I can't really simplify it because this depends on which block I go from. Yeah, so I might just add a quick check real quick that a feed doesn't rely on the block, I guess. Yeah, I'll do that real quick. I think that should be pretty easy. Yeah, let's do that. So we want is what dot. Okay, I guess we can just start with an if. So we can cast it to a terminator, just branch putter. Do that. Get rid of that again. What's wrong here? Oh, whoops. So if that is a branch, so that dynamic cast works, and then I guess like so if terminator branch and so the other thing I want to check is if the successor has a feed, then we just don't do this, I guess. So I guess we just want, is there an instance where, okay. Is there an instance where the predecessor matters for this? It's just if the successor has a feed, it's easier just to leave it as is. Yeah, I guess we could just do this. Oh boy, okay. Oh no. So we want dynamic cast to MR instruction fee putter, and then Jesus Christ. Yeah, ignore how ugly that looks. So if that, then we can eliminate that as well. What do we want to do here? What's the logic? Oh wait, there's one more thing we need to check. Determine be, I guess like want the instructions size or empty and all that stuff. Do we have an instructions already? It doesn't look like we do. Okay. Okay, that, so that does that. Jesus Christ, we're making such a mess. I'm scared we might have like a double erase here actually. Actually no, we shouldn't. This should be fine. Yeah, I like it this way, I think. This allows us to optimize more aggressively. This is the most conservative, I guess, of the four here. I don't really care about eliminating fees if only one successor yet. Actually, that shouldn't be that hard though. Okay, so let's do this. So, how do we want to merge this? We want to just skip over this. We can kind of link this sort of thing like this. Yeah. Okay, so we wanna change the successors. Yeah. Right? Oh wait, no, this makes a mess. This actually makes a little bit of a mess. How long have you been studying and are you worried about work? I've been doing this, I guess, like, sort of informally for like 1.5 years now, but I've been streaming for almost 50 days. I'm not particularly worried about work. I got school, so school is school. If that takes up a lot of time, then I'll probably just focus more on that. But that's like, bottom line is like school comes first, but I don't think it's gonna be that large of a problem for now at least. Okay, low-key, this one's a little bit more complex to implement. This is really annoying. Yeah, I guess we could do a little bit of dynamic casting. Can do this gross thing again. So we want pred, get terminator. We can do this. Have you considered teaching the C++ slang while writing out your solution? That's only if you think there's demand for it. I've thought about it. I don't know it at least well enough to, I guess, give a lot of explanation, but also, like, the explanation is, like, low-key a lot of work as well. So that's why I've been, like, trying to avoid that as much as possible. But if someone asks, like, a question, I always try to give some sort of explanation. Like, once I think someone asked about, how smart pointers work and how they're different from just standard pointers. So I gave like a little spiel on that. I think that stream was like a week and a half ago. I don't remember off the top of my head though. Maybe it was 2 weeks, damn. Yeah. Yeah, that's like the short answer. If there's any questions, just like let me know. I'll explain to the best of my ability, but also no guarantees that I'm able to explain anything, I guess. What the hell? I have never seen that double brace before. Okay, so we also want to do this again, but with C branch, conv branch. Okay, so if it's a branch, then so regardless, for each successor, oh wait, fuck. Yeah, because we need to do like a union, I guess. Do you use a NeoVim distro or is it custom? I use my handwritten config. So the predecessor is a branch. Oh wait, if it's an unconditional branch, then oh my god, wait, this okay, we just need to union them then, I guess. Okay, so this is predecessors, and then we need to update successors somewhere. So we went to unions. So we want to union those and update. Do that. So we can do that, and then yeah, okay, I think this is sufficient. We could just turn it into a set, but that's like low-key. Yeah, that might be the fast way. Okay, so we want third set of threads. Set of oh wait, no, I'm stupid. Successors does not grow without bound. We just replace the one that is this branch. Yeah, okay, so pred sucks. So this is pred, its successors. Actually, I can do this even. Right. And then we want to do the replace thing here. So I want to replace that. We want to replace all occurrences of basic block with we just want, we also want new successor. can even just, this is a one-time, right? So we can, yeah, this should have a successor, right? What's wrong? Oh, sure, okay. Yeah, so that should work. And then we need to update the actual thing. Yeah, this code is looking very spaghetti the more I look at it. Okay, so unconditional branch is pretty straightforward. We just want to replace branch. We want a successor. So I'm going to set this to what? This. Let's replace this with new successor. And then this should be new successor. Not assignable? Oh, right. There we go. Okay. Okay, this is gonna be really stupid. So there's only a true and a false successor. So if this equals the basic block, then if it's the true successor, then con branch, we want to set t successor to new successor. Otherwise, we know it's the false, so we can just set that like that. We can even get rid of these braces. Can we get rid of these braces? No, we can't, because that will be ambiguous. Okay. So then this is fucking horrific. I hate what I'm writing here. Yeah, so this resolves predecessors. And now we just need to clean up the successor. Wait, we can even just do this as we go here per predecessor, I think. I guess we could just make a quick little set up here. Unordered set. This is a basic block footer. So this is this is successor preds. And this takes in BB, or we want sucks 0 get predecessors. Can I just do it like this? I need to add an unordered map. Or no. Set. Alright, what's wrong now? Also, what I'm missing here is... Oh, Jesus Christ. Okay, let's... This also needs to be not, because it needs to not be a fee. So we want... Oh my god, I hate this fucking code I'm writing. This is the worst. This is actually the worst. So we want... So this is successors 0, get predecessors. And then this should be... This is terrible. Okay, so we just create a set that contains all of that, and then so we do this. We can't even just stick a continue in here. Yeah. And then one other thing we need here is I fucking hate the way this code looks. This is like such a mess. I feel like I've just written a rat's nest here. Okay. What was I working on? I need to, if this doesn't contain pred, then we want to add this I'm going to insert, or I'm going to push back pred, and then I'm going to insert into the set. Okay, so that updates that updates one side. The rest of the stuff updates the other side. Yeah. I really hope I did this correctly. Okay, I definitely didn't do something correctly here. Ah, fuck. Yeah, this is fine. This looks fine, I think. Yeah, because these all do things. This is fine, because this doesn't break anything. Okay. I think this one might be where we run into problems. Okay, yeah. Okay. So let's comment this entire thing out. Okay, what is this? Where are these straight line connections? This 4 has something. We're getting rid of 2 here. So 2 has 1 predecessor. We want to replace the right label. Yeah, so we replace the label for that. Maybe I should just step through this. Yeah, let's step through it. Yeah, we're using a mouse. Okay. Jesus Christ. Let's simplify this a little bit so it looks a little bit less horrific. Let's also do so we kind of need to do it like this, I think. Actually, no, we don't need to. So if dynamic cast successor has fee. And then we can pull this out. And put that there. So this gets its own line. Should be that. Then we can continue. Jesus fucking Christ, I hate this. So we can do successor 0 even to straighten that out a little bit. Okay. Holy shit. I hate this so much. What is this? Should be by reference. It should be by reference. Not be by reference. This is a dynamic cast. Those should be fine. Oh wait, we fixed it? Oh wait, no, we didn't rebuild it. Okay, well. Alright, let's comment this out again. Okay, let's step through it. So what are we doing at 2? For each predecessor, so this only has one predecessor, which is this one. So for each predecessor, oh wait, we can pull this out as well. So we want a single successor here even. Change these. Oh wait, we can literally just okay, that cleans it up a little bit at least. We should also put this up here as well. I can also just put this up here for now. So add a to-do for that. Yeah, okay. So we can just handle that as we go. Okay, so for each predecessor, so it's just 0. We get its successors. We replace, yeah, okay, that makes sense. So if it doesn't have that, then this should, that's by reference, yeah, that's good. Alright, so that handles that. So this handles each predecessor, or each successor. Maybe I could clean up this logic a little bit, just mentally. Replace successor preds. Successor preds. So I do that. That's by reference. That should be fine. It's a putter. pred basic or pred terminator blocks. Yeah, that should be fine. I don't see what's going wrong here. Let's make Valgrind. It's a bracket operator. Oh, wait. Oh, I see. So this needs to be either... So we want... We want, want it to be not empty, and okay, there we go. That looks a little bit less ugly. And this should work now, I believe. Aha, okay, perfect. So that cleans it up a little bit. This is a little bit inevitable, but it is what it is. Okay. So the final test pile. Let's uncomment everything. Okay. Yeah, these branches are a little bit funny, but it looks like it all works. So, yeah, yippee. Yeah, okay. I don't think there's an instance where we like literally get rid of a fee somewhere. So, like a fee in value. Maybe we run test on like call chain real quick. I feel like that would be interesting. Oh yeah, that cleans up a lot. Yeah, this looks way less ugly. What else would be interesting? Get rid of that. I'm curious what DT turns into as well. It turns into segfault, I see. Why the fuck does that segfault? Skip that one. That's not good. Okay, this is fine. What the fuck else does it try to do? Oh, it might try to simplify some straight lines somewhere. There's no straight line to be simplified there. Oh, there's a straight line there. Right? Wait, what? Oh no, there is no straight line there. There's a feed there. Ah, there's a straight line here, it looks like. So I'm gonna add to 9 there. So what's wrong there? Is it like a visit order thing that's going wrong? No. That wouldn't make sense. Okay. Maybe we have like a double visit or something. Let's include IOStream. BB. Yeah, I think this will be the last one I do today, though. I'm quite tired. So, yeah. And it's like 12:30 my time now, so... and then finally... that. We want I should probably do like each run. Okay. So what the fuck is going wrong here? See, invalid read by type. Binary op. Merging straight line is where it's fucking up. Let's see. Oh, we gotta combine the values. I see. Yeah, we gotta combine the values. That's what I'm missing. So we want. I can't believe I have to write a getter for this, but I guess it makes complete sense. What is this ID? This is NeoVim. Alright, we need literals. Literals. This is what we need to merge. Yeah, so let's just reference and just make a getter here. Yeah, I know this is like bad practice. At this point we basically have a struct, but yeah. We want literals. Okay. Maybe I should just do like a merge, but so we want insert range exists. How do I do this? Okay, so we want to insert at end, I guess. So we want bb get literals. Oh wait, no. We want pred arrow get literals. So we want pred get literals and we want maybe we could make a little bit less of a mess out of this. And then and then bb literals begin end. Oh my god, we can't do that. So we want literal for each literal in bb get literals. Want I'm gonna push back, move. Want to move L. And then this should work now. I hope this works. Well, fuck. That doesn't do what I want it to yet. Okay, I should get rid of these print lines real quick. I feel like something is gonna make me reinsert them later, but I'll worry about that when I get there. Alright, where does this vomit out now? Fee? At a fee? The fuck? Where's it coming from? No, the instruction definitely still exists. Because we literally move it into the thing. Right? Yeah. Yeah, all the instructions still exist. Oh, fuck. Do we need to clean up the fees as well? Oh, no. Oh, no. Oh, fuck. Yeah, because which block do we get rid of again? We get rid of... I think 8, yeah. Or we get rid of 12. Yeah, so this fee is a little bit broken now. Okay, so we should iterate through next fees. Because this is a straight line, so we can clean that up, but yeah. So this is fine, and then we want to change the fees. For each instruction in oh, we also need to do, yeah, we need to do in here. The instructions. Dynamic cast. Instruction fee footer. I'm gonna take I get. If it's a fee, then so it's not a fee, then we can break. Otherwise, we want fee. So if it's processors, yeah, so processors, it contains basic block. Or if it doesn't, then we can continue. What's good, Michael? Welcome to the stream. I'm hoping I can get this debugged so I can like go to bed and like be a normal human being. So if it's not a fee, then we break. If it doesn't have the basic block, then we skip it. So then otherwise fee. Yeah, so get predecessors. We want so I'm gonna erase basic block, or wait, what does erase return? So we want to get the value is a putter, so that's fine. And then we want fee. Let me just check the list of stuff this has. It'd be very nice if it has what does the extract do? Oh wait, that's so funny. Wait. Let's give this a try. So we want fee, get predecessors, and we want to extract. And we want to extract at basic block. I've never used this before, for what it's worth. So it's gonna be pretty funny. So with that, and then we want get predecessors, and we want to insert yes, we want the mapped. Yes, we want to set that to mapped, and then the predecessor we want is pred, I think. Right? Yeah, we want pred. This is like such a hacky ass solution. Are you writing C compiler? Yes, I'm writing a compiler that goes from C to x86. I cannot tell if this changed at all. Oh, it didn't change at all. And okay, it works now, in theory. It looks like it does what we want it to. It's as if the block was never there. x86, yep. There's not really any rational reason behind it. I mostly just want something that can like run natively on my computer. Yeah. But also the idea is that it'll be extensible. Compassion Nasm? Ooh. Fun stuff. We don't have 10 and 12 anymore, I think. This is merged, I think. Yeah, because this is... Where does... Oh, Jesus. What did I do? So we don't have 10 anymore. 10 is the first one where it really differs, I think, right? Or no, 12 is merged in. 12 is merged into 8. Yeah, okay. So we have add 1, and then we have another add 1 there. Yeah, okay. Yeah, that works. Okay. So I think that means we've done all of the major debugging. Do we have this issue in any of the other blocks? For the dead blocks we don't need to worry about because the fees literally do not contain the values, and we literally cannot get to the values unless we did like a backwards traversal. The straight line connections, I think we've just worked out everything. And then the fees avoid, or like the empty straight line instructions, we just avoid blocks of fees. So yeah, that should be fine. Working on IR now? Yes. Yeah, right now I'm kind of just messing around with passes as well. over the past few days, I've just implemented mem2reg from scratch and added control flow to the subset of C that I work with. Yeah, so it's a pretty good time. Yeah. Let's see. Okay, all the tests still run, which is to be expected. I would be very surprised if they broke at this point. What happens if we... What's a nice program we can fuck around with? Yeah, all these are quite boring, to be honest. DT and if are the only... DT, if, and phi assign are the only interesting ones, I guess. Phi... mem2reg register allocator, not quite. It's the LLVM pass that that converts stack variables into virtual registers in the IR. And that sounds simple, but then you realize that the IR is SSA form, and then all of a sudden it becomes a complete mess. If you're not familiar with SSA form, it's the property that each reassign is treated as a new variable. And that's what I was doing with all the fees and stuff. Because when control flow merges, you need to figure out which, I guess, like, which new variable you read from. Yeah, okay, clutch. Yeah, so mem2reg is just SSA construction with stack variables, I guess. That's the short explanation. Yeah, SSA it's a bit of a doozy, but the algorithms are pretty well defined, so I think it's more just a question of like having to get it done rather than struggling too much through it. Yeah, if you're going from like stack variables to SSA variables, my only suggestion is that you should avoid getting into the weeds with like the variable renaming stuff and just treat stack variable load and stores as defs and uses, I guess. Or other way around, uses and defs. Generate tac from AST and then nothing from the IR. I see. Yeah. That seems like a pretty standard, pretty reasonable way to go about it. I throw in a couple more IRs because I think it makes it a little bit cleaner to figure out what does what, but I feel like it's all stylistic at the end of the day. Phi insert, this is the one. Okay, let's just make sure this builds, okay. Yeah, these little nubs are inevitable. I'm trying to think if there's a better way to clean this up, but I guess I could probably just, wait. Oh, I see. These are literals. Okay. What can your compiler do for now? Pretty much just like instruction calls. Yeah, instruction calls, some basic binary operations, and if statements right now. No parameters for anything yet because I'm lazy. And then it also handles scopes properly, which was kind of funny. Yeah, it's pretty minimal right now, but I'll be adding for loops, or just like loop structures in general soon, actually. I think my existing infrastructure should be able to handle it. Can it do Fibonacci? Not quite yet. Because I don't have function parameters yet. So I can't do it recursively, and I don't have loops yet, so I can't do it iteratively, which is really funny, but give me a week, I should be able to get it to do Fibonacci, I think. Also, I don't have a backend yet. That's the other really big problem. This is all just like optimizer level right now. I just haven't had the willpower to, I don't have the willpower yet to start tackling the back end. I've done it once before. It's a little bit scary to me to do it again. So yeah, that's kind of how it is. Let me just start committing stuff. Is there anything messy that I have left here? Why is this assert in here? A ping pong and raylib using the programming language. Ooh. Yeah, I mean, if it compiles at all, that's already like really huge. Like correctness is the #1 goal of a compiler, and then speed is second usually. But it's very rare that a compiler doesn't want to be correct at least. So you've at least done, I guess, the minimum for that. Yeah, register allocation and like all the assembly optimizations are like really scary to me. They're just so outside of my knowledge. So here what did we add to this? Straight line connections. Most empty blocks. Okay. So yeah, it is almost 1 AM here now, so I should probably start getting to bed. The fucking career fair is tomorrow, so I should probably get going soon. Started to read a book about rank compilers and skip register allocation. Man, yeah, I feel like that one is probably the most interesting part of the backend, at least. Just because of how it maps onto like various other problems. Yeah, I don't know. It was just pretty cool to me, but yeah. I'm gonna head out now. Thank you all so much for being here and showing up to my stream. It really means a lot to me, especially at like this fuck-ass hour. I'd imagine a lot of people and a lot of my regular viewers are probably sound asleep at this point in time. So yeah, kudos to y'all for sticking with me here. Make sure you like the stream if you haven't and sub to my channel. It really helps get my content out to more people and I guess gives me a little bit of a bump on the algorithm. And while you're down there, make sure you join the Discord. That's the best place to get pinged when I go live, and also chat with me off stream and chat with the community as well. Yeah, while you're down there, make sure you connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. Yeah, thank you all so much for the support. I'm gonna head to bed now. Take care, y'all, and take it easy.